Hello. Daily Math Blast 12, two-step word problems. Sarah put 23 books on the shelf and the librarian put 13 more books on the shelf. Ralph came behind them and knocked 17 books off the shelf. How many books are still on the shelf? Well, first I'm going to write an equation to match the story. So Sarah put 23 books on the shelf. So I have 23 books on the shelf. And the librarian put 13 more books on the shelf. Well, the operation symbol for showing that more books were put on the shelf is plus 13. Ralph came behind them and knocked 17 books off the shelf. So I'm knocking, that would be minus 17 books off the shelf. How many books are still on the shelf? So that's what I'm trying to find. So I'm going to put a mystery box there since I don't know that number. So there's my equation. 23 plus 13 minus 17 equals something. Now I just need to choose a strategy. Now remember, the strategy that I choose may be different than the strategy that you or your teacher uses. I'm going to use a place value chart. So I'm going to start with tens and ones, since that's the place values of the numbers that I'm adding together. So 10, 1. So I'm just going to simply, this is kind of my shelf. That's why I like this strategy for this problem. So 23, I'm going to place those books on my shelf. So 3 ones and 2 tens. Now I'm going to place the 13 books on the shelf. 3 ones, 1 10. Okay, now I need to knock books off my shelf because Ralph came by. So 7 ones and 1 10. So I look, I only have 6 ones. So I need more ones so that I can knock off 7 of them. So I'm going to take a 10. I'm going to unbundle or decompose it. So I'm going to put an X on it to show that that's the 10 that I'm unbundling. Draw my arrow to show it coming over to the ones place. And now 1 10 is equal to 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's my 10 ones. Now I can knock 7 books off. 1, 2, 3, 4, 5, 6, 7. Now I'm going to knock 1 10 off. So one of the things, notice that I put an X when it unbundled, and I use a diagonal mark to show that I'm crossing it off. That's how I can tell which one I've unbundled and which one I've crossed off. So I've crossed off 1 10 and 7 ones, and now I'm just going to count up my ones and my tens that I have remaining. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have 1 10. So 9 ones and 1 10, or 19. So 19 books. Add and subtract within 20. So I have 11 plus 3, and I have 16 minus 9. Now, you may be fluent with these, which means you can kind of do them in your head, but I'm going to show you strategies that we could use to solve these. So 11 plus 3, well, 1, I could use the counting on strategy that you learned in first grade. So I'm going to start at the 11, and I'm going to count up 3. So if I count up 1, that's 12, 2, 3. So 13 and 14. So that's a way to show that count up strategy. So I started at 11, then 1, 2, 3, and where am I at? I'm at 14. Now 16 minus 9, I'm going to go back to that place value strategy. So tens and ones. 16, 1, 2, 3, 4, 5, 6 ones. 1 10. Now I'm going to cross off 9, so I look here. I do not have 9 ones. So put my X, unbundle it over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So remember that 10 unbundles to become 10 ones. And now I can cross off 9. So here's 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7. And 0 tens, so 7. Now remember, when you're doing the place value strategy, it's very important to be very neat. Notice I put them in rows of 5, like a 10 frame. And I like to make circles instead of just dots, because then it kind of tells it's easy for me to tell the difference between a stray pencil mark and an actual counter. Partition a rectangle into rows and columns. Hannah is making a pizza for her family. She wants to partition or divide the pizza into 3 rows and 4 columns. How many same-size pieces of pizza will Hannah have? Well, when I'm breaking things up like this or partitioning, one thing that's kind of handy to remember is, think of it like if I was cutting this, if this was a piece of bread and I was cutting it. If I have 3 rows, remember rows go side to side, so I want 3 pieces. Well, if I draw one line, it breaks it into 2 pieces. If I draw 2 lines, it'll break it into 3 pieces. It's kind of like cutting bread. So I need thirds. There we go. And I want my pieces to be as identical as possible. So there we go. So I got my 3 rows. Just remember, rows go side to side. So here's my 3 rows. And I like to kind of put 3R and 4C. It just helps me remember so I don't have to keep looking back at the whole word problem. Now I have 4 columns. Remember, columns go up and down. So the same thing. So if you think of this as a piece of bread or something, so I need 4 slices. So if I slice it once, I'm going to get 2. If I slice it twice, I'm going to get 3. So if I slice it 3 times, I'm going to get the 4. So I'm going to slice it 1, 2, 3. So I can see 1, 2, 3, 4 columns. And then I've got 1, 2, 3 rows. And now it says, how many same-size pieces of pizza will Hannah have? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 pieces of pizza. Identify coins. Put an X on the quarter, circle the dime, shade the penny. So I have a dime, nickel, penny, quarter. So we've been kind of studying these coins. We know the dime is small. It's one of the easy ways to identify it. Then we've got the penny. He's facing the other direction. We got the quarter. That's the largest. And then kind of the one in the middle here is the nickel as far as size. So put an X on the quarter. So we'll put a big X on the quarter so the teacher can see. Circle the dime, the smallest one there, the dime, and then shade the penny. That's the person, Abraham Lincoln. He's facing the other direction. Shade. Okay, so I put an X on the quarter, circle the dime, shade the penny. Explain why addition strategies work. Jerry bought 17 tickets at the fair. His brother gave him 9 more. Sally had 9 tickets from last year, and she bought 17 tickets when she got to the fair. Do Jerry and Sally have the same number of tickets? How do you know? Explain using pictures, numbers, and or words. So remember, your explanation may be slightly different than mine. I'm going to look at it as kind of the situation. I'm going to look at Jerry. I'm going to look at Sally. I'm going to see if they're equal or are they different. And then I'm going to use my work to prove it, and I'm going to write a sentence to kind of wrap everything up. So let's look first at Jerry. So Jerry had 17 tickets, and then his brother gave him 9 more. And then we had Sally, who had 9 tickets, and she bought 17 tickets when she went to the fair. And we want to know if they have the same number of tickets, and then we have to prove it. So how do we know? And we need to use pictures, numbers, and or words. So I've got to have some kind of work to prove it. I can't just say equal and they are equal. So I have to have some kind of evidence. So 17 plus 9 and 9 plus 17. I'm going to use our place value strategies from earlier. So let's look at tens and ones. So 17, 1, 2, 3, 4, 5, 6, 7. And 1 10. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I had 0 tens there. So now I need to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now remember, once I get 10 ones, I can bundle those together to make a 10. So I'm going to bundle them up, move them over, make a 10. So now 1, 2, 3, 4, 5, 6 ones over here in my ones column. And I have 2 tens. So I showed that Jerry has 26 tickets. Now let's look at Sally. Tens and ones. So 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus 17. 1, 2, 3, 4, 5, 6, 7. My 110. Now let's count up our ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now remember, once I get 10, I can bundle those, move those over to make a 10. 1, 2, 3, 4, 5, 6. 2 10s. Okay, so notice Jerry had a total of 26 tickets, and Sally has a total of 26 tickets. Well, 26, when I compare them, let's look. 2 10s, 2 10s, 6 1s, 6 1s, those are equal. Okay, so that's my work. Now I need to explain it. So I've kind of used pictures and numbers. Now I want to throw some words in there to kind of wrap up my answer. So I know Jerry and Sally have the same number of tickets. Because, now what did we notice? We noticed that 17 plus 9 is the same as 9 plus 17. So the only thing that we changed, the add-ins or the numbers that we added up stayed the same. The only thing that changed was the order, right? The 17 came first, the 9 came first. But notice in both cases, the sum or the answer remained the same. So because order does not change the sum in addition. Okay, now we have a special term for this in mathematics, and your teacher may have worked with you on it. We call it the commutative property. So the commutative property states that the order of add-ins, when we change the numbers around, the order that we add numbers together, it does not change the sum. It does not affect the sum. So we call that the commutative property, is another way of saying this. Okay? Now remember, with all of these problems, the strategy that you use to find the answer, it could be different, but the answer, the sum, the circles, the x's, those should be the same. So this was Daily Math Blast 12. Thank you.